Okay, so we've just been through our basic noise and turbulence nodes, the two nodes that we're going to be using for building up more complex natural phenomena textures. Before we go too much further, let's have a look at three basic techniques for working with these textures, with these nodes. First thing we're going to look at is parameter distortion, using noise and turbulence nodes for distorting the parameters of other texture nodes. I've got here a grid, a polygonal mesh grid, and it has a Lambert shader on. What we're going to do is we're going to use a noise or a turbulence node, doesn't matter which, to distort parameters on a ripple shader. First of all, let's set up the ripple shader there. Plug it into the diffuse input. Let's have a look and see how that renders in the preview region. Okay, that's not quite right. We need to set up the UV parameters properly in the texture. I'm going to give it a planar XZ texture projection, and there we go. There's our ripple. Okay, not that it's particularly relevant to noise texturing, but I'm going to go through the ripple parameters, or just a few of the ripple parameters, so that we can be clear about what we're doing with the noise nodes when we start distorting some of these parameters. If you want to see what the rest of them do, and have a look under the question mark here, there's a fairly good explanation there, or look through the documentation. Okay, first of all is the frequency. The frequency controls the frequency of the ripples. The higher the frequency, the tighter the ripples. Okay? The amplitude, the greater the amplitude, the more intense the highlight or the white areas of the ripple. These are the two colour inputs here. They're currently set to black and white. The other one we're looking at is speed. This is the speed with which the ripple travels. As I increase that speed, you start to see that at this particular point in time the ripples have moved further out. And time. Time is controlled independently in this shader of the XSI timeline. You have to animate the time for yourself with this parameter here. If I make it 1.5, for example, in seconds, then it's spread out a little bit further to it's spread out further still. Notice that it's gone blank in the centre there. This is a ripple in the pond type ripple effect, rather in the same way as you throw a stone into a pond, the ripples spread out and then gradually dissipate, leaving the centre calm. So the same happens with the ripple shader here. And that's really, there's the origin there as well. If we change the origin, we can shift the point at which the ripple is emanating from. So that's just the basics of the ripple shader. So what are we going to do with it? Okay, well, let's get a noise node, exactly as we did before. Again, you should be looking in the user path. I'm going to dig up from the workgroup application because I'm using shared shader installs. You can use either of these, either the noise or the RGB. It makes no difference at this stage. They'll just produce slightly different, well, more than slightly different results. It's obviously a little bit more critical when we have specific goals in mind for our shaders, but at the moment we're just playing around. So I'm going to use the turbulence node. Right. And what I'm going to do is I'm going to use the turbulence node to drive the frequency. There we go. Plug that into the frequency. It's put a colour to scalar node in there for me automatically, converting the RGB output into a scalar for the frequency input. Not particularly expected what we're seeing there. All it's done is just lower the frequency considerably of that ripple there. And part of the reason for that is that we haven't set up our UV coordinate inputs into this turbulence function here. So let's do that now. Generator, I'm going to use a projection input there. Plug that directly into the coordinate. And I'm going to create a new spatial texture. Remember that this is a 3D texture, the turbulence node. Okay, so what's it done? Well, again, it's not all that clear. But what it's doing is distorting the frequency. The higher the value of the turbulence function at any given point on this surface here, the more it's going to, the higher the frequency is, and at the blacker, darker areas, the lower frequency. there's still the sort of remnants of a ripple there, but it's not hugely useful as it stands. We need to add a little bit more control to it. So what I'm going to do is I'm going to use a math node. This is a change range node, which is a scalar node, and I'm going to place that in between the color to scalar converter and the frequency there. Now the idea of this, if you remember looking at our ripple property page, we originally had a frequency of 17.5 in there. If I remove that, 17.5 frequency gives us this kind of quite tight ripple. Remember that the output from the turbulence function here is going to be in the range about 0 to 2, 0 to 2, 0 to 3. Remember, this is the function, this is the node that adds together noise functions. So when we plug it back in here, it's going to be giving the frequency values in the range 0 to 1, which is very low for the ripple. So we want to change this a little bit, and the change range node is the thing that we use to do that. If we set the input range, we'll leave it at 0 to 1, and we're going to remap that 0 to 1 input range to of the order of 15 to 20. There we go. Still not brilliantly clear, but that's because it's distorting it an awful lot. There's still quite a wide range of frequencies there. So I'm going to lower this color output there to something a little bit more there. Okay. If I lower that right down to 0, you can see we're back to the sort of range of ripples that we were looking at before we started plugging all this lot in here. The reason why it's absolutely nothing there is because I've turned the turbulence color down to absolute 0 there. If I was to plug the turbulence RGB directly into the diffuse, you'll see it will be all black. So we're going to have constant. We're going to have constant frequency across there when we plug it back into the ripple. If I increase that slightly, you can see some values going in there. And we've got a little bit of turbulence in there. If I plug that back into the diffuse there, you can see it's just very slightly distorting that ripple. As I decrease that, you can see it's still distorting it a little bit, but not quite so much. And going back to the change range node, I can change the output frequency. If I want to make that slightly less, I can change that 10 to 15, and we're getting more spread in the ripple. If I want to make tighter bands in there, I can, let's make that say 30 to 35. I can make them very tight, and then again go back to the noise function and increase the value of the color in there to increase the amount of distortion that's going on in there. And again, I've got access to all of these all of the parameters of the noise function to change the character of that as well. Let's move this back down and get some bigger ripples in there so that we can see a little bit more clearly the actual characteristics of the noise there. Okay. So if I, for example, increase the linearity, then I get a slightly noisier noise in there. If I lower it back down again, it becomes slightly smoother. If I increase the frequency, then obviously I'm going to get a much higher frequency noise in there, and you see it distorting even more. So that's one technique for using noise nodes to manipulate textures. That's one creation node. We're getting a little bit short of time on this video now. But in the next video, we'll take a look at two more techniques for using noise and turbulence nodes within textures. One will be how we use it with color, and the other one will be for UV distortion, for actually distorting the UVs to get patterns on there. But that's it for this video.